We start by graphing y equals tangent of x. Why do we start there? Because this equation here is the same thing as this equation. The only difference is that this graph is translated uh, pi over 4 units to the right. So it's the same graph, just translated. The question is, how do you graph tangent of x? Well, you need to find where tangent of x is undefined. So at pi over 2, tangent of x is undefined. So when it's undefined, we draw asymptotes. So at these two places right here. Now how does the graph behave? Well, we start at 0, and then we have a curve going up. Try this again. Going up. Approaches the asymptote but never touches it. Okay. Now, that's when x is positive. When x is negative, it's this same curve, just reflected about the origin. What do I mean reflected about the origin? That just means it's flipped upside down and then flip to the left. So I'm gonna select to reposition a little bit. Select it and then make a copy. Then flip it upside down and then to the left, and then grab it and reposition it, and boom, we have our tangent function. All right, let's analyze it. What is the period? Since start 0, pi over 2 to the left, it's negative pi over 2, and then positive pi over 2 to the right, that means we have two halves. So the period is 2 pi over 2, and it's just pi. Now, my asymptotes. Well, I just told you my asymptotes right there and right there. Pi over 2, negative pi over 2. My x and y intercepts are both at 0 because we start from the origin. Okay, so that's my y equals tan of x. So this function calls for a translation of this graph pi over 4 to the right. So I'm just going to grab each half and translate it pi over 4 to the right. Right there. Grab this one and right there. And so what happened to my asymptotes? Well, same asymptotes but shifted. Well, not the same asymptotes. Now we have negative pi over 4 because we shifted it pi over 4 here. This one is going to be 3 pi over 4 because we need to shift it pi over 4 to the right. Okay. Now, what is my new x-intercept? The x-intercept is easy because we're translating to the right. So we translated pi over 4. So my new x-intercept is obviously going to be at pi over 4. The y-intercept is not so obvious. If I were using a graphing calculator, I could clearly see that my y-intercept would be at -1. But like I said, when you're drawn by hand, you can't really see, so you need to resort to calculations. So let's do some calculations. We start with the original function. Y equals tangent of x minus pi over 4. So at the y-intercept, x equals 0. So let's substitute x. Tangent of 0 minus pi over 4, which is the same thing as tangent of negative pi over 4. Now, there is an identity that says that tangent of a negative angle is actually equal to the negative tangent of the angle. So here we have the tangent of a negative angle, and this is the same thing as a negative tangent of the angle. So that means y equals negative tangent of pi over 4. And I happen to know that the tangent of pi over 4 is 1, so it makes it negative 1. So right here we would have a negative 1. Okay, so I got my intercepts, my asymptotes for the translated function right here. Now we're going to do this one. This is the same thing, tangent of x minus pi over 4. Same thing in this one. The only difference is that we have a negative sign in front. When you have a negative sign in front of a function, that means just turn it upside down. That means change the sign of all the y's. So what I do in this case, I'm working with 2 halves. So I'm going to do the first half first and just turn it upside down. Then work on the other half and turn it upside down. And right there. That's this graph right there. Now what happened to the asymptote? Well, when you're translating across or about the x-axis, you don't have to recalculate the y-intercept. Just put a 1 here. It's going to be a 1. Now the x-intercept, of course, remains the same, and the asymptotes remain the same. And thank you for watching.